Well, thank you very much, Josh. I really appreciate the kind introduction, and I'm really excited to speak on aviation and speak with you today. It's a huge passion of mine, and an amazing area for the future of our economy and our society. And today, really, what I want to address is that change and what the change in transportation that we're going to see in aviation really means for all of us. Now, you can have whatever you want in the metaverse, but in the real world, transportation and logistics are what knit our society together. And when you change that invisible fabric that we take for granted on a daily basis, you change everything. And what we're in the middle of right now is that type of a change. So today, what I want to talk about is three main things. First of all, what the impact of those changes is going to be. And really what we're going to see is greater population dispersion. We're going to see a complete restructuring of freight and logistics, and that's going to mean a reorganization of business assets. And then we're going to see what I'd call an onslaught of aerial robotics, where small aircraft are going to change many of the ways that we do work and we perform tasks on a daily basis. And that's pretty exciting. In the process, we're going to have a cleaner, more efficient transportation system, and we're going to have a much, much bigger aviation and aerospace sector than we have today. But before we get into that, I want to ask you guys a quick question, which is, what do you think is cheaper on a capital cost basis for moving a person a mile? An A320 aircraft, a car, Toyota Camry, a helicopter, or a pair of running shoes? We're just talking about capital cost now. How many people vote for the A320? Okay, we got a few takers. Who thinks the helicopter is the cheapest? All right. And what about the running shoes? Anybody thinks the running shoes are the cheapest? Okay, we got a lot of runners out there. We'll come back to that in just a minute. But before we do, I want to talk a little bit about where we're coming from, which is commercial aviation. And we take what commercial aviation has done for us for granted because it's part of that invisible fabric. But if you went back to our grandparents' time or great-grandparents' time, it's amazing how much commercial aviation has actually changed the world. We have fresh raspberries in the middle of winter. You can get fresh flowers all year round. We send our kids overseas to school. We don't think much about going for a 4-day weekend to Baja California for tourism. We have overnight package delivery. All of these things would have been completely unbelievable to people before World War II. It's just something that was not in their realm of experience, something that just wasn't possible. And the question really is, how did we get there? How did this happen? And not only how did it happen, but why did it happen? We know the output, though. Over the last 70 years, aviation's grown at 3 times the pace of ground transportation, and in terms of passenger miles moved, passenger miles moved, and it's going to go up to 6 or 8 times that growth over the next 30 years. So an amazing change. So we get back to the capital cost for this. So the capital cost of running around in your Nikes is about 20 cents a mile. Helicopters about $1.80. Cars about 40 cents. Commercial aviation is 1 cent of capital cost per passenger mile. That is just unbelievably efficient. I mean, it's a miracle. And how did it happen? It happened through 2 things. First of all, it happened through scale. So if you think about DFW or Heathrow or JFK, the scale of those facilities is enormous. Grand Central Station in New York is a dot on the map compared to that stuff. And the aircraft are huge, right? An A321, if you pack them in the way we do at Volaris, can have 240 seats. Cars have 4 seats, right? Small scale stuff, right? And the technology is also amazing. Like an A320 can operate consistently for 10 to 12 hours a day for 330 days a year. Try doing that with your car. It's not gonna happen. And that enables you to get to that incredible cost efficiency. Now, this kind of deployment of commercial aviation in cars has created a very interesting transportation issue in our country. And issue is probably not the right way, it's a paradigm. So over 500 miles, you've got this kind of miracle of public transportation that's hyper efficient. By the way, flying around point to point on a commercial airliner is the equivalent of about 130 miles to gallon in a car. And then under 50 miles, you've got car transportation. But in the middle, you kind of have a mess, right? Driving a car 250 miles is not a lot of fun. You're sitting in a confined space. Flying for 250 miles, you have to go to an airport, and you spend in line, an hour in line at TSA, and then you spend some time on the other end. Just not a very efficient way to get around. And what that's done is, it's done something to our pattern of development. So we have 150 big airports around the country that have 95% of all the commercial aviation traffic. Those airports and those urban centers are served very, very well by cars out to about 50 miles, maybe 100 miles if you live in LA and you don't mind the traffic. But everything in between, regionally, is sort of broken. So you end up with places like Cave Junction, which is in the middle of this graphic. And Cave Junction is a place in Southern Oregon, incredibly impoverished, really cut off from the dynamism of our large cities. And what's going to happen over the next 30 years is changes in aviation are going to fix, and other technologies, including Zoom, are going to fix this missing middle issue for us. And what are those changes? Oh, thank you. There's really two key changes that are changing aviation. And they're going to give aviation what I call its small is beautiful moment. Or for those of you who have tracked the computer industry over the last 40 years, as everyone in California has, sort of the mainframe to cell phone moment. And those two technologies are electrification. So one of the reasons that aviation, commercial aviation operates at massive scale is propulsion is very, very efficient for large aircraft. So a 777 has a turbofan engine on it. It's about 65% efficient at converting energy into momentum. A small aircraft like a Cessna 206 is more like 25%, so less than half as efficient. And electrification changes that. It makes propulsion in small aircraft as efficient or more efficient than in large aircraft. And the second thing is autonomy. And autonomy allows aircraft to fly with no pilots, unmanned, or drones, as a lot of people call them. Now, autonomy is interesting not because you're replacing the pilot, and as a matter of fact, for a lot of manned aircraft, I think it's going to take a long time to replace pilots, but because it makes entirely new kinds of aircraft possible. And a simple example of that is power line stringing, where you used to need a $2.5 million, $3 million helicopter to do that. Now you can do it with a $100,000 drone. And by the way, it's a lot safer because, if you take a helicopter and you fly it around a bunch of power lines, that's not a very safe thing to do. So these two changes are really going to change aviation, and they're going to enable aviation to break that 500-mile barrier where commercial aviation is stuck above right now, and provide lots and lots of use cases, personal transportation, freight, and all kinds of robotics applications in that sub-500-mile envelope that has really been dominated by cars. 97% of passenger trips, by the way, under 500 miles are done by cars. Okay, so how is that going to happen? There's going to be three main areas where this is going to have impact. The first is in passenger transportation, the second is in freight, and the third is in aerial robotics. So in passenger transportation, we have a very interesting situation today. So if you look at the cost to travel a mile in a car, it's about 58 cents. And most cars only have one person in them. So it's a pretty good proxy, even though you could fill a car up to 4 if you wanted to. To take sort of the cheapest 9-seat aircraft, small aircraft, it's 75, 80 cents. Some people would say, hey, if you want a pressurized aircraft, it could be over $1. It's not very competitive. And even if you get up to 19 seats, it's not very competitive. And so what happens when people have a choice between going in a car, which has a huge amount of flexibility, or going via air under 500 miles for twice as much? They choose cars, right? I mean, people drive to LA instead of flying to LA, even though the flight only takes an hour. All the infrastructure, the cost, everything else, once you get there, they'd rather take their car. So cars dominate under 500 miles. Now, with hybrid electric propulsion, other kinds of new advances, and autonomy, we're going to see that cost position between cars and aircraft invert. So aircraft are going to become cheaper than cars for many of these trips under 500 miles. And we know exactly what happens when you invert the costs like this, because we've seen it before many times and in many different ways. People start to shift modes. Now, this is a great example of a business that was on the wrong end of a mode shift. This is an interstate Greyhound bus. And I know this use case very well because in the early 1990s, Greyhound came to Bain & Company, where I was working at the time, and said, hey, we've got this great interstate bus network, but we're losing passengers and we're losing money. What should we do? And we told them the answer they didn't want to hear. We said, you should get out of that business, because Southwest Airlines is not only faster at getting passengers there, they're cheaper at getting them there. You're dead. Get out. And so that's what they did. They dismantled most of their interstate bus network where they were competitive with Southwest Airlines, and the passengers continued to shift from ground to air. And by the way, this is actually the premise on which we started Volaris in Mexico. When we started Volaris was only an idea in our heads, but we knew two things. We knew that fares had been going up every year, and passenger traffic was flat in Mexico. Everywhere else in the world, fares had been going down, and passenger traffic had been growing 1.5 times GDP. And we also knew that Mexico was the largest bus market in the world. 10 years on, a little more than 10 years on, we had tripled the size of the Mexican aviation market by cutting fares, getting those fares down below the buses, and switching people and getting them out of traveling on ground transportation and putting them in the air. So there is nothing new to this story, and it's happened many, many times around the world. What's going to happen in regional aviation is we're going to be doing that with cars instead of buses. Now, there's a lot of other dynamics that are playing into this besides transportation costs, and we're going to see this again when we talk about freight and when we talk about aerial robotics. Transportation costs leverage big assets, and that includes people's personal assets, their homes. So what we've got going on right now is a very interesting sort of dual-track technology change. On the one hand, we have remote work, which enables people to stay at home 2-3 days a week, commute from there, work from there, and go into the office 2-3 days a week. And on the other hand, we have this changing economics that are coming up in aviation. And what that does is it changes how land use works. So if you can travel, do a thought experiment in your head for a second and say, if I could drive my car 250 miles an hour and I never had to experience traffic, and by the way, it was 1,000 times safer than driving my car of today, would I live someplace different than I do right now? And the answer for a lot of people is going to be no, but the answer for a lot of people is going to be yes, especially when they're working from home and they want a little more space in their house. And the reason for that is that the costs of that house right there decline linearly with the distance from the urban core. So if you're in Palo Alto and you decide to buy a house there, it's going to be about 6 times as expensive as buying a house on a square foot basis as buying a house in Tracy, which is 55 miles away. And so if you need the extra space because you're working at home and you can get 6 times the asset for your money, there's going to be a lot of people that move. And we know this is true. We know this is true because it's happened before. At the end of World War II, hey, has anybody been to the Tenement Museum in New York? Okay, pretty amazing museum, right? I love that museum. And for those of you who haven't been there, basically the answer is people lived about 8 rooms to a floor with 1 bathroom, and there were 10 people a family in each room. And at the end of World War II, we had this great invention, which was the highly reliable, very inexpensive car. And people said, you know, I really don't want to live 10 to a room with a bathroom down the hall that I share with 6 other families. I think I'm going to move out to a suburb in New Jersey. And all of this, that was possible because low-cost auto transportation enabled people to get access to the land that gave them low-cost housing. This is what's going to happen with aviation and better transportation into exurban and regional areas. And it's going to create regional integration for dynamism into some of those poorer areas back into the dynamism of the big cities. So pretty exciting, and it's also going to be very controversial because a lot of urban planning has been, hey, let's build up, right? Let's put people in condos and stuff like that. There's a place for that. There'll also be a place for this. Okay, so let's talk about freight for a second. This is our second main area. Freight is going to change a lot. And when you change freight, you change the organization of commercial assets. And we'll talk about that in a second. But what we're really talking about here is 2 types of freight that'll be changing. One is mid-mile freight, which is moving goods under 500 miles. Sort of think of it as kind of regional distribution centers to factories and back and forth, right? And then there's last mile freight, which is the last 10 miles, delivery trucks and things like that. Now, why is freight important? Freight is important because of the last roll of toilet paper problem. So it may seem like goods have a single price, but you would be deceiving yourself if you thought that that was true. Because if you buy a package of 24 rolls of toilet paper in a Walmart, you're willing to pay a very low price for that. But you're willing to pay a completely different price for 1 roll of toilet paper when you're sitting there and you're looking at the center of the toilet paper ring and it's showing you brown. There's no paper on the outside of it. And this is a positional, temporal element of purchasing goods. And if you don't believe me, all you have to do is look at the statistics. Air freight is 0.1% of total weight of global freight, and it's 8% of the value of freight moved. Expedited freight is growing at 6% a year, which is 2 or 3 times the rate of general freight growth. So there's clearly a value to time in freight. And this is what aviation can bring. And by the way, it's even worse on the commercial side, right? Because you don't have the cheap part that costs $1. You don't have 1,000 of those. And so what do? You shut down the entire factory because you can't build anything. This is why the most important department in any manufacturing plant is the expediting department, because they're the ones who prevent the factory from shutting down by getting the parts there on time. And a couple of friends of mine from Ask Computer Systems are in the audience today, and we spent a lot of time trying to figure out how to build software to get parts there on time, because if they don't get there on time, you're making an incredibly valuable asset idle. So let's talk about the last mile and how that plays out in some specific use cases for drone delivery. So this is Matternet. Matternet's a drone delivery company that is really focused on delivering medical tests, organs, and things like that. And the idea is you take your blood sample, you put it in a little container, you bring it up to a kiosk, and this is the lab tech doing it. You use a QR code to identify yourself, scan yourself in. It puts it into an elevator in the kiosk, loads it onto a drone, and the drone flies off to the testing center. Now, what's the advantage of this? You'd say, wow, that sounds like a pretty expensive way to transport samples. And with lack of scale, it absolutely is an expensive way to transport samples. But the answer is, no one really cares how much it costs to transport those samples, because you've got a completely solid chain of control, so you're not sending dangerous blood samples around in a car driving around a city, but you've also got a very, very high degree of reliability about when you're going to get that sample to the testing center and get it processed. And why does that matter? Well, if you don't get the test done, that person might need to spend another night in a hospital room. That's very expensive. But even more powerful, if you don't get the test done, you might delay an operation. And an operating room that's delayed is $10,000 an hour. So you could pay almost whatever you wanted to get these samples here and back in a reliable way. And by the way, if you do that, you probably extend the range of delivering those samples to testing centers, which means you could potentially consolidate testing centers, build bigger, higher throughput machines, get higher asset utilization on those machines, and you end up with a much more efficient asset use throughout the medical system. So this is happening today throughout the world in various places, and I expect to see a lot more of this as an early use case in drone delivery. Here's a little bit more futuristic example. So we all know that we have a huge network of restaurants around the country that deliver food. They basically deliver meals to people's homes, and people have built big delivery networks for that. But if you really think about how the assets for making food for people at home is organized, yeah, there's a little bit of ghost kitchen stuff going on, but not much. And so what you really have is you have a whole bunch of kitchens that are set up in the highest priced real estate imaginable, right? Retail, real estate, and commercial districts with subscale kitchens, subscale purchasing, and then impossible delivery conditions where the delivery drivers have to go into places where it's really hard to find parking to pick stuff up in a subscale way and deliver food. So will all of this stuff get restructured because you've got high-speed transportation option with drones to move food around? I don't know. I mean, it could happen. And what's more, it has happened. So famous entrepreneur in the United States, Fred Jones, this guy on the left, famous black entrepreneur, he invented refrigerated trucking in 1939. And before refrigerated trucking, there was really a set of ice cream stores that were around the country that were all local. Everybody made their own ice cream. And the reason they did that is you couldn't move it. It would melt. Now, when he put together a refrigerated trucking system just before World War II, and that began to run out after World War II, or play out after World War II, what we ended up with was a massive consolidation in local ice cream, and Dryers, which was run by a gentleman who lived in Piedmont, California, passed away just recently, consolidated the ice cream business nationally. And instead of producing ice cream in every little town and locality, he produced ice cream in a few large centers around the country. Now, did that eliminate the local ice cream store? No. Did it eliminate local production of ice cream? No. But a huge segment of the business became consolidated solely because of changes in transportation economics. I'd submit to you, we're going to see changes of this type. What they are, I'm not quite sure yet, but we'll see changes of this type as a result of all of these changes to logistics and transportation and aviation over the next couple of decades. So let's get into the third area, aerial robotics, or what we call the wild world of drones at Diamond Stream. And Josh gave us some great examples of this across not just aviation, but other areas. But what's amazing is just when you drop capital costs, you increase the scope of use cases massively. Just think of the App Store on an iPhone. And this is exactly what's happening in aviation right now on the drone side. It's a little more complicated than people thought about 10 years ago, which I'll get into in a second. But some of these things are just incredible. We've talked about power line stringing, which is the lower left. I love this one right here, which is a robotic hawk. And they fly these things around airports to scare birds off to limit drone strikes. I mean, who thought that up? Incredible. And the third from the left on the top row, if your local cell tower goes down, Verizon will drive out a tethered truck with a generator on it, and the tether will be tethered to a drone, it'll lift off, and it'll provide temporary cell phone coverage until they can fix the tower. So amazing stuff, everything from tracking penguin numbers to estimating forest sizes to saving people who fall overboard in the ocean. So this is all pretty amazing stuff. There's a proliferation of use cases. It's really unclear how all this is going to play out. But what is clear is one of the biggest sectors in this industry is going to be surveying and inspection. And I'm sure many of you have seen The Money Pit. Anybody here seen The Money Pit? Okay, everyone, yeah. How many of you lived The Money Pit? I've lived The Money Pit. I remodeled a house. And this is what you feel like. You feel like you're being consumed by your house when you get into one of these things. And this is what the people at PG&E, who were running PG&E, must have felt like in the middle of the last decade. And you know, if just for frame of reference, I lived in Africa for a while. Africa's an amazing place to live, but once you get out of South Africa, you drive around, there's nothing there. I mean, there's just no infrastructure. There's no buildings. The roads are all dirt. You come back here after being in Africa, and there's just stuff everywhere. As a matter of fact, we're tearing it down because it's not high enough quality and replacing it with better stuff like we've done here. And so when you have a really old set of infrastructure like PG&E has, and that infrastructure doesn't have very good records, for reasons we'll talk about in a minute, you literally feel like your infrastructure is consuming you. You can't keep up with the challenges associated with maintaining this stuff. And this is going to become a bigger and bigger and bigger problem for our society as the infrastructure that we've built over the last century has aged. Now, that brings us to the campfire. So if you think about the implications of this, it's really quite profound. So PG&E's got 40,000 plus miles of transmission lines in the state of California. And those transmission lines probably have 5,000 or so towers. A lot of those transmission lines are actually acquisitions that were done at the beginning in the first half of the 20th century. None of those companies kept records. PG&E hasn't kept really good records. And this stuff is hard to inspect. So the campfire started in a place called the Feather River Canyon. And the transmission lines in the Feather River Canyon were acquired by PG&E in the first half of the 20th century. The company kept no records of what they did, but they had this typical kind of setup. So they have a set of insulators that protect the tower from the transmission line. And at the top of that set of insulators is this thing called a C-hook. And that's a 2-inch thick piece of iron hook that's holding up those insulators, and those insulators are holding up the wire. Now, this thing swung around in the Feather River Canyon for 100 years. Windy place. And the Feather River Canyon, if you've never been there, is a very, very isolated place. Like some of these towers, you can't even drive up to them, right? You have to hike to get to them. And you can't inspect this stuff by helicopter because if you get the camera close enough to actually be able to take a picture of how worn that C-hook is, you're going to be close enough to arc the current from the power line into the blade of the helicopter. Extraordinarily dangerous thing to do. Helicopter inspection isn't possible. So one day in 2018, in a big windstorm, one of these C-hooks finally sheared off. Power line fell to the ground. Wind was blowing at 50 miles an hour, and the result was the Camp Fire. 18,000 buildings destroyed, structures destroyed, $16 billion worth of damage, 89 people killed, the entire town of Paradise destroyed. And you know, I think PG&E probably did not have the right inspection system for this, but I also feel for them, because to inspect one of these things, you have to get somebody to hike up a canyon, climb up a tower, and look at this and take a photo of it from the tower. That is not a trivial task. Drones can solve this. And by the way, you know, people 10 years ago thought, oh, I'll just fly the drone up and take a picture. It's not that easy. You have to fly up to that tower, and you have to know exactly where that drone is in space. And that means that you need a GPS signal on the drone, but you also need a ground station so that you can position that drone exactly. You need a very high, somewhere probably between a 40 megapixel and 120 megapixel camera to take that. Then you need image processing on the back of it. For a lot of these things where you're not looking at point inspection, you need to stitch all of that together, and then you need analytics to manage that on the back end. That's a very complicated, very high technology business model just to inspect a C-hook. But that's where we are now. And we've got that technology, and this is going to be a huge growth area for the economy. So some tough things have happened in the past. Drones are going to help fix this, and unmanned aviation are going to fix this. So what's the result of all of this for aviation? The result of this is a massive growth in aviation, and this is just the drone business. So there's about 300 million drone flights last year. By 2029, there'll be 7 billion plus drone flights. Enormous growth in drones, in drone flying. And the biggest piece of this growth is not going to be in those little DJI drones that you see. It's going to be in this area called complex drone operations, which is either flying beyond visual line of sight or flying multiple drones in concert with each other to achieve an effect. And that kind of thing is particularly important in firefighting, by the way. And that particular segment, complex drone operations, is going to grow 26,000 times over the rest of the decade. That's not 26,000%. That's 26,000 times in terms of flying. And this is going to make the aviation business much bigger and much faster. So I'll just finish up with a couple of things quickly here. The business is going to be much more profitable. Aviation's been moving from sort of a commoditized selling capacity model to a much more sophisticated business model, even on the commercial side. The technology integration on the aviation side is really going to leverage high-value assets, which is going to make the business less price-sensitive. It's going to create higher switching costs. It's going to have lower capital costs, which we've talked about. It's going to have less volatility from external shocks because it's less reliant on petroleum. And it's going to be less subject to labor disruption, classic labor disruption, because it's going to look more like a high-technology business. So we're going to have a much bigger business. It's much profitable in aviation and aerospace than we had before. So in conclusion, this is really going to change society a lot, you know? We're going to see population dispersion. We're going to see a restructuring of logistics. We're going to see a lot of aerial robotics. And it's going to make things a lot better for all of us. It's going to help us maintain our infrastructure. It's going to help solve the housing crisis. It's going to give us regional integration. It's going to make business much more efficient. We have a lot of obstacles to overcome to get there. We have a lot of people who get very energized when there's airports in their neighborhood. It's hard to develop this stuff, but it's going to happen. And I think you guys are the leaders in this space. We can all make it happen together, and we need to overcome those obstacles to get to this bright future. Thank you very much.